In part 5.1, we're going to look at chemical reactions, and this is just an introduction here in this first part. So, a physical change is something that's going to alter the physical state of something, and so that means that it's not changing what it actually is or its composition, it's just changing how you find it. And so the example that we have here, as you see, is the water. And with water, you can have solid water, you can have liquid water, or you can have gaseous water or steam. And so we're changing the states, the physical states of water, and so that's a physical change. A chemical change, however, is going to involve a chemical reaction. And a chemical reaction is where I'm going to actually change the composition of what I'm starting with. And so I'm going to change one substance into something else, into another substance. And so those chemical reactions are going to involve breaking some bonds, okay, that are in the reactants and forming new bonds in the products. And so we react reactants to produce products. One way that we can show this or symbolize this is by using what we call a chemical equation. And a chemical equation uses the formulas for all of these compounds and other types of symbols that are going to allow us to kind of define what's going on. And we're going to show the reactants and the products. And we always are going to write those reactants on the left-hand side of the arrow, and the products are going to be written on the right-hand side of the arrow. And then we're going to use coefficients, the numbers, such as the 2 here, to show the number of molecules of each element or compound that's reacting. So reactants react to produce products. And so what this is telling me is I have 1 molecule of methane, 2 molecules of oxygen. Those are the reactants, and they are going to react together to form, is what this arrow basically is telling us, 1 molecule of carbon dioxide and 2 molecules of water. Notice that if I have 1 of something, I don't write the 1 because it's understood. And so this is the overall chemical reaction for the reaction between methane and oxygen. One thing that is very important in chemical reactions is, is the law of conservation of mass. Okay, so the law of conservation of mass tells us that matter can neither be created or destroyed, and you've probably heard that before. And this is in a chemical reaction. The coefficients are what we use to make sure that we balance those, and so sometimes you may see this called a mass balance. A mass balance. So, and what happens is you have to have the same number of atoms on the left-hand side as you do on the right-hand side of a chemical equation. So when we look at these, remember, I can't change this subscript, because if I change that, I'm changing what the compound is. And if it's methane, it has to be CH4. If it's elemental oxygen, it has to be O2. Now I'm going to rearrange those when I form the products, but I can't balance with these numbers down here. I can only change the coefficients. So in this particular example, I have 1 carbon, I have 4 times 1H is 4 hydrogens, and then I have 2 times 2 is 4 oxygens. Then when I combine those two things together, I'm going to combine them to form carbon dioxide and water. And the reason that I'm going to have 2 waters formed for every 1 carbon dioxide is because I have to have the same number on the right hand side as I did on the left. And so when I have 1 carbon dioxide and 2 waters, I have 1 carbon, 4 hydrogens, because you multiply everything in the formula by whatever the coefficient is. So 2 times 2 is 4, and 2 times 1, because remember we don't write ones, but it's understood, is 1, okay? And then, so 1 times 2, sorry, is 2. And then we got 2 more oxygens over there, so really this one is 2 plus 2. Okay, so I have 4 oxygens, and so I have the same number of atoms on both sides, which gives me a mass balance. So just some symbols, if you're not used to these, just know these, that you'll see an arrow means that that's the reaction. You're forming something, so that whatever's happening, your reactants are going to be on the left-hand side because your arrow's pointing that direction. The delta, this stands for heat, and when I have a formula such as sodium chloride and I put an S there like this, that means it's in solid form. If I put an L, it means liquid. G stands for gas. And aqueous, so sodium chloride dissolved in water, would be NaClAq. So those are some symbols you're going to see as we write these chemical equations. And so that's the end of part 5.1.